Hello and welcome to wasmCloud Community Call for August 5th. Today we've got a couple things to talk through for what we've landed after 261. But also, I just want to start with potentially a demo. Aditya, are you on and able to share your screen? Oh, you're not able to share your screen, but I'm going to do it right now. Okay, how about now?
Yep, just give me a second. Hey. I hope you can see this.
I'm not seeing anything yet. Is anybody else seeing stuff? I know it's just me.
Yeah.
That's
We're
it. I see Bailey of Bailey. Oh,
VS Code. Yeah.
Yeah,
Oh, okay. All right, it's up now.
okay. So I hope this is visible. So basically, there is a tiny problem that comes to people when they try to experiment with WasmCloud and starting new WasmCloud components. Let's say you're a beginner and you're just trying to explore WasmCloud. You're not necessarily going to know anything about how to start your own Wasm component, except for the docs, which are really great. But someone who's entirely new to the whole ecosystem, uh, you might be really confused. And with the examples and templates that exist in the Wasm Cloud repository, uh, made me think, why not just expose that to people that want to try them out as a form of a wash command? And meanwhile, at the same time, why not let people uh, create their own custom workload architectures? So I came up with a command called wash wizard, uh, which sounds a bit mystical, but hear me out. Okay, so if you hit enter, it it creates this whole selection screen for people that are trying to design the new components. The first option is a custom architecture, which I'll show in a bit. But the other options are taken directly from the template source, such as the HTTP API with distributed workloads, the service TCP, and all the different components that exist in our examples and templates folder. And when people enter any of these, it just does a very simple git clone. So just to land some kind of pretext, there's the subcommand for wash new that allows you to directly git clone a subdirectory within a given repository, allowing you to directly copy and clone and run any Wasm component in a given directory that has a .wash config YAML. But what this does is it just skips that whole, ooh, where where is this said component in this said examples directory, and it allows people to just okay, I have the file system view on the left here, and if I just hit enter here, it should just do a git clone and turn us the entire uh, subdirectory. And similarly, if we have, let's say, community contributions in the awesome Wasm Cloud repository, which is now spun up by Bailey, if I just do a enter and wait, oh, oh, never mind, that broke a bit. But what's theoretically going to happen is the awesome Wasm Cloud components that exist in that repository, they're also going to get loaded up into this wizard so that people can choose from that pre-existing directory. And wizard is just going to be a simple catalog for people to view things really simply. And the most important thing is having your own custom architecture, being able to understand what your entire workload is going to be like. So if you do this, it goes into a cool wizard setup where there's three kinds of triggers as of now. There's HTTP, messaging, and service. Let's say I choose for an HTTP ingress, and I want it to be P2. The P3 one keeps bugging out on my local machine. I don't know why, but for this demo, I'll keep it strictly for P2. And the linking part is, let's say if I have two or more components that I want to be including in my entire workload directory, I can choose the number of steps. And on the right side here, it shows you a really clean view of how your components are going to be interlinked. Let's say 3, 4. I mean, the whole terminal view is a bit wonky, but you get what I mean. And if I choose for fan out, it gives you a whole bunch of branching operations with being able to choose the branch depth, the number of branches, as well as the branch depth for each individual branch, so that let's say you have an ingress pointing to different branches, and those branches in itself have different component chains. You can bootstrap them directly using this wizard. And okay, let's see. Let's say I have two branches, and I have one of them that is, okay, for the sake of this demonstration, I'll keep it to chain, and I'll keep it to one step. And capabilities. Okay, so let's say I want to be able to do config, and I want to be able to do WASI config on the ingress. So I can choose that, as well as the step 1. I can choose that as well. And I can keep doing that for all these capabilities, such as HTTP egress, which is the WASI HTTP outgoing handler. And I choose that for step 2. And once I hit enter, it generates this whole package called my workload. You can obviously specify this using a flag. And the interesting part about this is if you do cd my workload, and if you do wash build, it does the whole build process, and it gives you a workable boilerplate template for your application. If you remember correctly, step 1 had the egress, which is the outgoing request, and also the WASI config, which it pre-registers into a simple invoke function, which people can just edit. And the width is also readily generated as simple ingress and step 1 and step 1 component. And so this way, people don't have to manually create their own custom web interfaces without doing a very serious deep dive into what Wasm is, what WIT is. And it just allows them to have a really good experience with building Wasm components and being able to run them with wash dev directly. And I just think that having this could really boost the user experience that we have when it comes to beginners that are trying WasmCloud. And that was it for my demo. This is
really cool.
Yeah, I'm glad to hear that.
Are you up for some brainstorming? Do you mind if we do a little like
Absolutely.
Okay. My first thought was, what do you think about exposing language here? Or are we living in what world do you want? The Rust one at all times.
I mean, no. That was what I was going to discuss. We could totally extend this to having Python, TypeScript, or any other language that we want. I mean, just for the sake of demo, I kept it Rust only. But yeah, that is totally up for grabs.
To implement that, there's some interesting ways you could do it, and I wonder also with what you output, did you output a workload manifest as well?
With the wash config.
Yeah, I guess wash config basically is a workload manifest, so we could probably synthesize it. We could have another command that essentially synthesizes that into a workload YAML.
Yeah, I mean, I did use Claude to build this, but it does create a config.yaml, and a special thing called topology.yaml, which basically just creates a whole topological map of your entire workload, the node points, the graph, and it basically helps just show that preview and the wizard, like, hey, this component links to that, this does this, and yeah. Anything else?
I think the build your own workload is like obviously my favorite thing. I do want to like think through how would you surface even custom capabilities with it? Like for example, right now, um, we haven't really added too much yet in the host component plugin space, right? We just got the ability to create host components, and I started in on a couch-based one. We've got one that I started with as a host component, then opted to make it native. But I'm expecting very soon we will have a lot of different host components that people could add, and those would expose their own interfaces. And then I noticed you say that you can trigger with service, but obviously with service that would be exposing its own custom interfaces there as well. So just thinking through effectively user stories, right? Like in awesome wasmCloud, we have two different ways to connect to Couchbase. One is to the database API, which is like over sockets. The other one actually connects over HTTP, and it uses their data API, which a lot of databases now have, which is great for serverless functions. And so but not every cluster enables that, right? So people are going to want to be able to choose which one they want to use. So like even in this thing, even in the scenario of I want this capability, you may want to pick what flavor of that capability that you want that's using the exact same interface.
Indeed. But do you think it's more relevant to have something that just stubs the whole implementation rather than just builds the whole application itself? Because what I think people need as beginners is something that just compiles and just works
Yeah.
as a minimal first step, and which they can iterate on, which they can link as an additive step on top of that one. So let's say people are trying to build 0 to 100. You'd first want them to actually build the 0 to 1 instead of doing the whole 0 to 100. So having this first base of something that is WASI P2 compliant just compiles, and it helps them implement their own business logic, I think would be really meaningful. But I do agree that choosing the right flavor of the interface, it also makes sense, because you might not just want to just slap a single interface and call it a day. And
Yeah. Well, I guess that's my thought is like right now our dev host just gives you basically in-memory implementations for most of these interfaces, right? And I think if the goal is to get something that is talking to basically real workloads, right? And real workloads, they all connect to a database of some kind, right? I mean, that's what's an interesting app? It's an app that's interesting because it has interesting data. So from that perspective, I would think that we would actually have probably a lot of different host components to choose from that are all going to be an awesome wasmCloud. They're not going to be just like straight off the shelf WASI. And so in that scenario, I think they'll want to like pick it, and then inside the config YAML that you generate, where you generate the dev config, just you would fill in host component plugin, like that list, and just plop it right there. So hopefully that's not too much. And yeah, I think, I think I'm of two minds about the Rust versus other languages thing. That's why I was curious what you thought. If it's, I want to get you working right now, like, odds are you're gonna have the best time with Rust. And so I'm almost tempted to like have a default language setting for this thing, like a wash setting where it's just like, look, I only see the world in, black and white. Everything is Go or everything is Rust. And most of the people that I meet, they're exactly like that. So let them pick their basic one, and then we just always derive from that.
I would agree. So
Frank, you got a question?
Yeah, wondering. So this would be, I mean, like really for starting, this would be wonderful. And I'm wondering if you can use this then to build a component, and it's going to be part of something that you want to continue the integration. So that is it's just a tool that you can use in terms of really, and then how you register this, how does it become available in your um, in your repo so that you can see it and then you can use it.
Right. So basically, what I've implemented is a mechanism which walks through. Let's say you want a new component to be added into this catalog. Uh, the workflow is that we walk through the wit interface, the world.wit, and if the I believe it's the cargo.tom, if it contains wstud, and because WSCD does the internal binding for WASI HTTP incoming handler. That's not necessarily visible in the world.wit. So the ideal way is that when you have components that get added to the awesome wasmCloud repository, you would have a build step that would create the Wasm binary artifacts, and then you'd use Wasm tools or something similar to walk through its component wit, and through that you would build its own topology map using the using a graphical walker, and that would in itself create a topology.yaml, which Wash Wizard would read and gets added to the catalog. I'm not sure if this answers your question, because does it answer your question, Frank?
It does, but it also shows that this is, especially for a beginner, can be very complicated.
Yeah, no, the thing is, you don't need to do anything other than just build your component and make sure it just compiles to .wasm. And if you just upload it to awesome wasmCloud, I think we should have a CI step there that does the whole catalog updating stuff for Wash Wizard. And there's nothing that the beginner who's already a lot confused needs to do other than just build the component itself.
One thing I'm thinking about is if we can eliminate the topology YAML and put that metadata inside the Wasm OCI artifact itself, and also the Wasm artifact. So like one of my design goals, it's not exactly, we're not 100% there yet, but if you give me a .wasm, I can basically tell you how to deploy it, right? Like I know what secrets it needs now with the wasmCloud secrets change. I know what configuration you need. I know what capabilities you need. And so you could basically give me a .wasm and I can produce essentially the custom resource definition in Kubernetes for what it would need, the basics. If you give me the top level config YAML for your whole app, like what you generated, for the most part, that also could that I build this thing and this thing and this thing, and they all get this configuration right, your top level config YAML. And that, for the most part, gives you the topology, except it sounds like you've got... Did I just leave?
Yeah, you just
Yeah,
got
You
it's
did.
weird. It's like it was like mid-sentence and then like it looked like you dropped and then came right back.
Yeah, I think
Weird.
Zoom crashed. Neat. That's because I've been in 2 Zooms like all day, and I guess I couldn't handle it. WebAssembly CG is happening right now, in case you didn't know. So sorry about that. Well, what I was thinking through is that it seems like there's some attributes about the component and the overall workload. And I want to be able to package it all kind of like universally, so that I could just take that one thing and put it anywhere. And so I want to like look at what you've made and see what those metadata types are, and maybe that's something that we need to expose and config YAML or on the component itself as part of its build, so that it shows up in the custom metadata section of that component. you know, a lot of different ideas there, but that's where my head's at is like I really love the idea of exposing the architecture, right? Like this is designed for fan out and like this is the type of things that you would want to do with this. And service chaining as like a top level construct is something else that you had there. I love all that. And so now I'm like, okay, well, how would I generically give people this so that they could figure out how to run this in other systems as well, right? Obviously, I prefer you to run it in WasmCloud and our WasmCloud host and awesome WasmCloud, but one of my high level goals is so that you can build portable standard components, right? So cool. And also, if you put it on the OCI, it solves the registry metadata problem because you can just use OCI labels and annotations to do the lookup for everything.
Oh, yes.
And then you can cheat and make it really easy to add other people's stuff, right? So it wouldn't just have to be awesome WasmCloud. And I bet a lot of people are going to want to add to this. Now, again, I'm greedy here and I want them to add it to our awesome WasmCloud, but I'm also practical in that people love to get their own branding on things.
That is true. I didn't think of it from that perspective, actually. This is a lot.
Yeah, there's so many places you could take it. I guess the other thing that I felt like I got out of Frank's question was it's almost like I want this to be a plugin, you know, like I almost want to be able to customize this to how my company works, or at least like pre-populate this information with what I care about, right? Like, yeah, there's that community WasmCloud thing, but I'm corporate, you know, McDuff, and I want the McDuff components here, and that's what I want you to see first.
Yeah, indeed. So like a custom way to just override the awesome WasmCloud repo space. Except, of course, we should just keep it as a default there. And
Yes.
yeah.
I don't know if that was something that was I was thinking of Scrooge McDuck, but then I just like morphed it into something
McDuff.
strange.
McDuff is the beer on The Simpsons, I think.
Oh,
Kind of random.
okay. Now it's both. Yeah, okay, so yeah, my made up corporation is yeah, a brewer. That's good. That works for me. I like beer. Any other thoughts or questions for Aditya? I think this is a great idea and I love the effort on like getting more people using this stuff. I want to make sure it's all machine readable because in today's world, the 0 to 100 is can the LLM do it? And so that's going to be a big key part of it.
Really, I've got a demo that I'm working on with some of the new stuff, but maybe we save it till next week. But it's with all the new pool size stuff you've been landing. I'm blown away. Like WasmCloud go so fast. And I think you even have a few new things on the roadmap. I mean, I just did a test with the P3 web component and the pool size of my local MacBook. So totally not representative, entirely anecdotal, and I hit 60,000 requests per second. I'm impressed.
Well, I have a version that maybe we should just talk through the design of, since I'm now asking for another round of review. Thank you, reviewers. I'm sorry I've been spamming you a lot. It's building right now, and it looks like I've got something to fix. But I think probably worth just like taking the community through what this change will be, which is a 13.6x improvement for the HTTP throughput case. So I think most people will want that. But at first, I guess it's worth talking through how we got here. A couple weeks ago, we talked about separating stores. And I needed the separation of stores for a couple different reasons. Maybe an Excel draw here. And we did this, didn't we? I think we started drawing some of this. Well, let me I think I actually remember now where it was. It's in WASI P3. Yeah. Okay, so a lot of this comes from the new types of architectures we can build on top of P3. And the reason why we've been getting faster and improving is largely because of P3. But so much had to change underneath to expose that. And so when we talk about like what we provide today, like we have the host and we built a bunch of host native plugins. And that's WASI HTTP, for example, that everybody's using. And then we also have built-ins for wasmCloud, and a few others that a lot of people were popular, like Key Value, Blob Store, and then Aditya, which I should actually hand you the mic after this deep dive. Aditya has a PR up for adding async messaging with P3. And we're also intending for that one to be a built-in plugin as well. With wasmCloud v2, we had an entity type that is a service, and a service is triggerable over a WASI CLI run. And it's written this way, and the reason why it has like a single entry point and everything is because in P2 I can't really do reentrancy, or I'll deadlock. And so with the service architecture, this is how it had to be. But when you talk about what you're able to actually do with WASI P3, we can do all kinds of new architectures, like making your service itself be triggerable. And so with wasmCloud 2.6, we introduced the concept of trigger services. And obviously, I just kind of like renamed our existing kind of built-in version of this, which is WASI HTTP, but specifically it has to be P3 to be triggerable. And what we do is we've now put this piece on its own store, separate from what is running in the wasmCloud workload store. And because we have separate stores, now we can have separate lifetimes and managing concurrency separate from each other. And so I can do a trigger into the service store, which will create a task, and then that task would then spawn another task that's actually running on a totally different store. And so it can do that operation, and service isn't blocking while that operation is happening. And then it can service other requests that are coming in, and maybe it's sending it to the user's handle, then it's sending it to the product's handler. And it is awaiting, if you wanted it to await, to have egress back. And so you could change it and create basically a trigger service that actually acts as an API gateway, is one idea. I mean, that's just like one very specific type of thing that you could now build, right? We're trying to give you all the right building blocks. But the main thing I wanted to highlight here is that now you've got a store here and you've got a store here. And getting that layer in is what let me build host components, where essentially I had to figure out how to have a cross-store bridge. And once I had a cross-store bridge, I could have services, but I could also introduce this other concept of host component plugins. And they also would have their own store. But for the most part, they're more like a host-tenanted version of these same trigger services that I was talking about earlier. And so underneath, they use basically a lot of the same fundamentals. Now, because we have this created, and now we've basically wired up that we can have these separate stores, we can have this cross bridge, we can have separate lifetimes. Now I can do some really cool stuff, like well, not regress things. Let's not pull up my regression PR. Let's go over to this one, and I can hold on to separate instances of things, because now I've said, okay, my service state is actually totally separate from my stateless compute. So the stateless compute and the workload can go in service requests and potentially spin back down, but be written however you want them to be written. So now I'm able to have an instance pool. And so the instance pooling was awesome, and that was a really great improvement, especially for languages that have a slow startup time, because they have to like instantiate a whole runtime to be able to work. This is something that is possible because we're requiring these things to be P3. And so if they are P3, I can concurrently run on these instances. Now, this doesn't mean that it's parallel in that I'm concurrently running, which means I'm spawning different tasks, and each of them are asynchronous, so they're async awaiting, but they're not necessarily executing concurrently at the exact same time. Concurrency is what I'm solving. Parallelism, big different topic that I really am excited about with shared everything threads, but we're not there yet in core Wasm, so we're not going to approach it there. So by being able to basically have an instance pool of things that are surfacing HTTP requests, for example. And then also because they're just hanging out. So like right now, today, it looks like this. I've got 4 instances that are sitting in my pool. A request comes in, it picks one of them. And so it just goes one at a time. By doing a concurrent pooled instance, what I'm able to do is like this, right? Like I'm able to basically reuse each one that's available as requests are coming in, and that's why that's such a huge throughput improvement. So that's one of the things that is on its way in. Frank, I see your hands up.
Yeah, yeah, really, this is very cool. Let me ask you something on the bridge.
Yeah.
Because you just talked about it, but what kind of state are you maintaining? So is this the pool itself is going to live there, or if you want to do, I mean, retries and so forth, it's also going to live there. So what's the? Because I mean, I think that you have the front end, then you have the bridge that will be the smart expanding in terms of either virtual dimension, allowing for greater concurrency. And then you're going to have the service itself or whatever, the function itself, right? Is that the...
Yeah, I wish I had more detail on my diagram here. There's a lot I would like to talk through. I don't know if I can do it totally ad hoc, but
Yeah, actually, but just a parenthesis here. I mean, why don't we just move to P3 and that's it?
Yeah, well, kind of, I'm doing that. I like your thinking. So you can only have a P3 host component, and you can only have a P3 service trigger. So if you want an export on your service, you must be P3. Otherwise, you're gonna have a bad time. It'll fail.
Oh yeah, Aditya, I guess you have to update your demo for P2 PC.
I'm sorry, Aditya. Well, the reason why I can't just like get rid of P2 is a few different reasons. One is that, it's going to take a while for P3 to make it through into all the different language tool chains. So, for example, 3 months ago, I landed the ability to do WASI sockets, P2 WASI sockets, and the sockets, the crate's called sockets too, but it's like the crate that TokyoNet and in the Rust ecosystem, how everybody communicates over sockets. And what landed inside that, and because it's exposed in TokyoNet, now I can compile things off the shelf like SQLx without making any changes. And interestingly enough, without SQLx having to make any changes. So they just pulled in TokyoNet, which pulled in sockets 2, and then all of a sudden they're able to do WASI P2 sockets. However, if I'm just trying to build a component today and I say, yeah, import that SQLx thing, and then SQLx is like, cool, I'm going to do TCP net, then underneath that, it's going to do the sockets too and be like, yo, you need a WASI P2 socket. And so what comes out when you do that compilation is something that is importing WASI P2 and not WASI P3. And to fix that, well, there's the hack option, which I often reach for making stunt hack demos, which is like, oh, I'll just patch in all my own dependencies for the whole thing. But the real fix, right, is getting WASI P3. It's going to be a tier 2 target in, I think it's 2 weeks. Don't quote me on that. I can go pull up the roadmap, but soon, like very soon, I'm pretty sure it's in less than a month. You'll have the ability to say -- target wasm32 WASI P3 for Rust. That's the prerequisite for me to be able to then add config flags, effectively, basically a macro in the Rust ecosystem to say, okay, you're building, if you're building for Windows, do this. If you're building for Linux, do that. We also have the equivalent for P2 versus P3. And so we'll add that in once I'm able to actually say, if you are P3, go do this thing. If you want to see how to not do that, like how to stun hack it through, you can see my wstood fork, where I've done that before P3 is like a known OS target. But essentially, to get it to actually percolate through the whole system, you need it in the standard library, and then all of these library projects that build on top. For the most part, they don't even have to change, right? Like Sockets 2 is almost, it's not in stdlib for Rust because Rust has like a very light, thin std, but it's like, it's std adjacent, and that project will get it first, and then everybody else will kind of build on top of that, and it'll percolate through the system. And that'll be the case for essentially all of these different languages. So P2 is going to be around for a while. And honestly, swapping my hat off from my wasmCloud maintainer hat, putting on my WASI co-chair hat, it's going to be around for a decade or more. And so that's how long I'm going to have to provide support for it. Just know that P2 is not going away, but yeah, you build for P2, you get P2 capabilities. And I'm really great that I'm building things inside wasmCloud that's going to encourage people to get off of P2 and start giving us feedback on the thing that we're actually trying to standardize now for on our road to 1.0 for the component model. Those are great questions. Do you have more?
And sorry, now you're gonna get.
Oh gosh, yeah, I'm kind of rambling.
Of your bridge.
Okay. Your question was where the state at? So in Wasmtime, which really, for a WasmCloud host, our answer is always, what does Wasmtime do for most of this? The state for these WASI APIs, for where the async bindings and how that's like driven through from the runtime talking to the component, and the component says, hey, I'm doing async stuff. And now basically the component model runtime, aka Wasmtime here, is saying, okay, like I know to await here, or I know that this is an async call. I'm going to help you spawn these tasks in these different places and wire it up to all these different components while you're doing the async calls, right? Where all of that actually happens in Wasmtime is just the store. So like here, this is the stateful bit. And that's also why we separate our stores between things, units of isolation and units of different lifetimes. That's why we break up into different stores. I can go on a totally different side quest here to talk about other things that we have planned in the component model called blast zones that would allow me to basically have these within stores, and I would kind of have a blast zone per isolated unit. That doesn't exist yet, but it's an idea that we really care about, and now you can kind of see why I would care about it when you realize that to build communication across different stores, if you want that level of isolation, is you have to create a thing like a cross-store bridge. But that's why we have that here. So where the state at? Let's say I'm doing a stream from a service, or actually here I've got it, I have the host component pulled up. So let's talk about that. I have a host component that is servicing something with HTTP, and then is going to pass that to another downstream component that called on it. So actually, yeah, we'll keep it that. So my host component created a stream and then is going to pass that on through the system. And the way that essentially looks like is that we essentially have this run concurrent call, which if you saw over here, we have these async hook calls. It's essentially how it's getting plumbed down underneath. There's some layers of abstraction and everything, so I'm doing a little bit of a hand wave to jump over the gaps, but that's effectively how it works. And so as I'm sending those async tasks, those are the things that I'm spawning. Then we create these little func new concurrent, and so basically, the one store has knows about these async requests and those async calls, and they get into an await state, or they're in a stream state, and they're saying, are there bytes to be read or are there bytes to write? Let me do it. And then on the other side is effectively the same thing. So like in a world where we're passing two streams, or one stream, but I have two stores. If I have two stores, I have two different things that are representing that stream. And they basically have a handle that I'm essentially pumping through. And when I measure this, it's the cost of a copy of going out of the stream, but you're doing it effectively in the same process. So it's still really fast. And when I measured this, the overhead of Doing this natively versus doing this with a component that's providing isolation, it's about 10% is the overhead today. And where that overhead is just, it's literally just copies for this part. But it's not like a huge copy because it's like the struct of the stream, but not necessarily like all the bytes of the stream. I can build a better diagram for this. It's kind of hard to describe, but that's fundamentally kind of like how it's set up. Now, with streams and all of these async calls, something else that's built into the component model that's important to know about is that it also has built-in cancellation and effectively like in a lot of ways error handling. So when we make a cancellation from maybe a call that's happening in the host component or on the other side from the workload, I need that to propagate all the way out and sort of clean up the state for all of these different things. That was probably a lot. Did that answer your question?
Yeah, I'm actually, it starts to.
Yeah, there's a lot more there. I guess the part that I'm like most excited about is that nobody else can do this, and it was a lot of freaking work. Like, I mean, we're talking at this point maybe 40,000 lines to be able to do trigger services as components, this cross-store bridge work, but also having a really nice isolated unit of host component plugins. And now, what I really want to see in the next couple of weeks is like us introducing a ton of different new host component plugins that just give whole new capabilities to the system really cheaply, really simply too. Like the components that you write for that just look like any other component, unless you need information about the workload, and then you just import our host interface that tells you what the workload identity looks like and what properties were passed in on the workload when it was defined. But you know, that combination of things means not only just this architecture, but another one would be another one that we can do really super well now is instead of just having to do this TCP loopback, which is cool and fine, we can actually just straight up, yeah, do SQLx coming all the way through and have a service component that actually has real, like, you know, like you can imagine it could be PG Bouncer, but for me, I built one that has SQLx because it's obviously my favorite, and that one's able to call out. And so I'm able to like scale different connection pools tenanted by the workload or tenanted by the whole host as a host component. And I can actually basically use that exact same component that I built for this service as the host component. And so people can essentially mix and match between all of these. Okay, I'm gonna take a breath.
I guess we're discussion time now, right? Let me, do we have a mechanism that, in terms of, I know that, I mean, like, for a lot of things in Wasm, we're using linear memory and so forth. But is there a place where I can have, let's say, an external resource that then I'm managing between my different components as my let's say flow moves from one component to another component?
Yeah, you know, I think it wouldn't be impossible to do a demo of exactly this to like explain the architecture to people if I did a WASI OTel component doing WASI OTel for WASI OTel. So like if I had a WASI OTel host component plugin and I had a workload that also used WASI OTel, I could attach an ID to that span that I'm creating basically and propagate it all the way through. And I could probably create a flow, basically a flow chart of exactly like when everybody along this chain touched it. And I think that would help. I think if I had an LLM go and make me, you know, essentially a flow diagram, it might be a little intense right now because of the tracking that we basically do of these tasks, but that might work out too. I think either of those approaches would be a nice way to kind of explain how all of this works. I mean, I mentioned it last week, like that's my big to-do is like just getting, you know, first I had to make it work. And now that it does work, now I need to create all these materials to kind of explain the power that's here that, you know, you basically can't do with anything else.
Yeah. Actually, I was just thinking in terms of if this could be extended using ring buffers in eBPF, because then you're not really
Yes.
copying any stuff. You're just sending pointers, and you're just managing how you're doing this.
I think that
yeah.
there's been some really incredible, there's two different projects that I thought are awesome. I'm pretty sure Liam's jumping in to talk about the Cisco one that was cool. But I'm a fan of I think it's called Euphorbia. Somebody had basically modified eBPF. Thank you, DJ. Eunomia. Which basically allows you to write user space style programs in the kernel. That obviously is essentially how eBPF works. So yes. Also, it's super easy to write a WasmCloud host, right? Like to have a WasmCloud host scheduled to places, all you have to do is provide the workload API. We right now, send that in over NATs with gRPC protobuf, but we could easily build a host that just instantiates from a manifest file, right? And that would be a great use case for an eBPF style host. Also, I think we could also have a host that just runs as your way to do sidecars in Envoy. I've got plenty of ideas, and it would be the WasmCloud workload scheduling API is way more ergonomic than the XDS one. So there's millions of different options there. The way to eliminate the copies is essentially, it's fundamental to how Wasmtime stores work. We could explore other options like Trust Me Bro type store work. I've seen plenty of people disable bounce checks, for example, for Wasmtime hosts, and find different ways to just share memory, basically, which we're not going that route right now because that basically weakens the whole kind of isolation sandboxing perspective of WebAssembly. But you could, and that's another option that could be on the table.
Yeah, I'm just wondering how much of the Rust concepts we can bring to this in terms of ownership, passing things along, and so forth.
Oh, we actually do bring a lot over. I catch a lot of grief for it, actually. So in WIT, you have a concept of a resource type. And so you basically have both owned and borrowed handles. And so we actually have that fully represented as well in that cross-store bridge, where we basically know who owns and who borrows, and that's a key part of the lifetime. And then obviously, or maybe not obviously, the streams, futures, these new canonical ABI types that are introduced as part of WASI P3, all of those have like very Rust-like definitions of their lifetimes. And that's also faithfully brought over in our cross-store bridge.
Yeah, that makes a lot of sense.
And that's kind of what I was talking about. Like there is a copy, but it's like the copy of the structure of like you've got a stream now. And then the bytes themselves are essentially pumped through. That's sort of a superpower of a lot of these approaches. I think there's plenty here to improve on the performance side. Like obviously I've been doing a performance spike, but step one, make it work. Step two, crawl, walk, run. But there's definitely because going all the way back to how I ended up here. Why can I do concurrent requests? Why can I do this performance thing? Initially, I brought to y'all, hey, how about I compose it all together and then I can just like reuse everything because now it's all on the same, basically they would all get their own store. But because we figured out how to basically do that without having to do the composition, now we get all of the benefits of our dynamic linking all, basically being able to build out all these things at runtime without me having to do that composition hack. And it was a lot of work to get there, but I think ended up better. And, folks like from Betty Blocks were like, Bailey, don't do that. And I'm glad you did, because we ended up with something even better.
Bailey, I mean, I just as like side of desk anecdotal evidence, playing with the new features today, and I'm just trying to wrap my brain around them. I put together a simple demo of a P2 component, and then a P3 component, and then a P3 component with the new pool size option. So only playing with one of the new variables. And not only am I getting just a 3x performance compared to the standard P2 component, but looking at my local system metrics, just running HTOP here, uh, the daemon is using 6% of the CPU. I mean, like I think there's a ton of room here to continue to roll out all these new features, and I can't wait to play with all the new stuff. I mean, I'm really excited to see WasmCloud finally get to the point with P3 and all the native async and everything where the sky's the limit here. So I think we're just getting started on performance on this.
Definitely just getting started.
And actually, just to add to this, well, performance and monitoring.
Yeah. Actually, we're not. I don't think, Jeremy, I'm not gonna put you on the spot for this. I'm only gonna like pseudo put you on the spot. Jeremy's working on something for us surfacing basically these metrics essentially on our heartbeat that include additional information that we weren't surfacing before. It's part of the monitoring story, but there's just there's so much. There's a plethora of things to do there.
I'm ready to share real quick.
Oh, go for it.
I had it ready to go. All right. Okay, so this is just a quick write-up inside Notion. Now this is a private Notion, and why can I not go away? Sorry. Yeah, so as you all probably know, I just learned recently, but when you compile WebAssembly components, it takes up more than one core instance space. And Wasmtime has, by default, a max of 1,000 core instances. So in Rust is way better with the way it uses core instances. It can be like 1 to 3 on average. But when you use Go, especially componentized Go, when it adds like various shims in place in front of it to make it so it works, it can add 4 to 5 per component. So if I take a typical WebAssembly host and I have one Go component that I compiled, and I thought, oh, it can run 1,000, and I go ahead and put 500 on there, it could use all of the core instances at once. And so now you're going to get this error that says maximum concurrent core instance limit of 1,000 reached. So basically, we need to protect the host. This is a time where you could have a noisy neighbor. It can exhaust all the host resources. Now this isn't really a I'm not exactly sure how 1,000 came up. I don't know the history behind Wasmtime, but and also based upon is it x86, is it 32-bit or 64-bit, all that. I mean, this number should be configurable. So that's one thing that's on the roadmap is just making some of these dials exposable. But the other thing too is we need to expose is having this so that inside the host heartbeat that comes back. Right now, we currently send the type of architecture, the CPU usage, the memory, the component count, workload count. So now we're going to go ahead and add in there to the host heartbeat how many of these core components, or I'm sorry, this is core instances are available. So if it is configurable, but also how many is currently being used. So what that'll do is allow for us to have it so that the runtime operator is smarter. We can have different thresholds out there so that if a host gets over like a certain percentage, say like 80%, the host can start warning saying like, hey, I'm about to get close to my max amount of core instances that are allowed. And then maybe even start throwing an error, like say around 95%. Since we do have host groups, that means the operator can simply order the number of the host in which it schedules components based upon which one has the most number of instances available. So it's just a better way to push out the work so that it's more distributed. So that way we're not using up all our core instances, because we really need to start treating that as like a first class resource type of property. Any questions? And honestly, this really came up with doing a one of the people that uses wasmCloud. They did a scaling type of test. I did a scaling test using auto scaling, Keta auto scaling, and it was on Rust, and never had any type of issue. But then they wrote the same type of thing in Go, and Go had the issue. And I was just kind of like, why would there be a difference in language? And that's when it really just went back down to certain languages compile, differently, and it really just kind of goes back full circle, Aditya, to you and Bailey talking about your Wash Wizard, and do we really need to know about languages or not? I feel like this kind of fits in with that story.
Yeah, Jeremy, did you test it with long-lived service invocations, and how
I
those?
have I have not yet. Yeah, so this is definitely on the list. Yes, to keep on working
Okay.
on.
Great discussion today. I think I'll just bring up the PR that Aditya has up. I see Victor's. I asked Victor if he would be able to review, since I've been in the WebAssembly CG all day and yesterday. Dropping a link to it. If you want to just give it a quick shout, Aditya. Oh, you're
Oh,
muted.
you're sharing it already. Okay.
Yeah.
Hey Bailey,
So
one thing about that review though, I left a comment, but basically, review aside, the mention that the trigger services should only be on P3, I think will change the implementation a bit more, because
Okay.
I think Aditya's got support for both in there. So it might
Yep.
be
I
worth
bet
it.
it'll deadlock. I bet if we create a unit test for it, I bet you can see that it'll deadlock.
Oof. Okay.
Okay, but well,
Yeah,
hey,
never called.
that's why we do code review. Well, Aditya, do you want to describe what this does?
yeah, basically this just asyncifies Wasm.cloud messaging interface. So under the 0.2.0 interface, the request was just a plain function. When the guest called it, the entire component instance was blocked until the reply arrives, or the timeout fires, and nothing else in that component could run. Well, with 0.3.0, we basically asyncify it with native async with P3 stuff, so that the component can have many operations outstanding and keep serving other work while each awaits. And the other one was that earlier in 0.2.0, the reply for a publish was a blocking call, which was nested inside a blocking handler. Now you can just await that from inside itself, which is really cool.
That's really nice.
Yeah.
Yeah, and for folks who are curious what it's like to create a P3 API, do you feel like you had to do a lot of extra work to go from P2 to P3?
No, not really. It was quite straightforward.
It's good to hear. You, me, and Mindy, I think, are in the special list of people who have gone and done it now, the migration. For the most part, adding async is the main thing, and because you get bidirectional streams, usually that's the other. Usually you're just deleting lines, has been my experience, because before you had to have incoming and outgoing and like think through like who's handling what and where, and now that kind of goes away. So it's been pretty good so far. I think because Yortis asked, what's the biggest gotcha in migration? At least What I'll say is, I think one of the reasons why there isn't a huge amount of gotcha is just that P3 is purely additive. It was a non-breaking change. So you can compile for P2 and add in types that are the native async types. And because of our tooling, basically, that we developed without having to require Rust and other things know about P3, inside Wasm tools, you do component embed. So basically, we take that information about it being async and stuff it into the custom metadata section, and then slurp it back out when we're making you the component. And that's how we are able to, it's kind of like a P2 component can almost be basically P3, but the difference is you don't have WASI IO. And if you do have WASI IO, everybody's going to treat you like you are P2. Which probably don't want, because then you don't get my speed ups. So I think that would be the gotcha. Is accidentally being P2.
Is this new interface about the NAT stuff we talked about it last time? So all the specification here is related to NATs only?
We did the easy thing first, which is just making it, just faithfully porting what we have, so that's what people are currently using. So we'll have that, but we also really want to do the NAT specific one, which I think is also the right thing to use.
Okay. Nice. Like it.
Hey, Bharat.
Hey, hi. So I was working with the my WASI AI app AI inference, and I checked the Mindy's work on the WebGPU, WASI WebGPU. So I was trying to get that into in our demo. But before that, I checked Mendy's work, Sean's work, and the WebAssembly Unleash podcast, all those things, and the Git repo code for that. So I like to know your input on like if we want to have that AI inference thing with WASI WebGPU. It is beneficial to add that backend to like a Candle framework, or we like to have our own code for WASI WebGPU. What your thoughts?
Well, what Mindy's been working on is upstreaming his work to places like Candle, but not Candle yet. He's done it for Llama CPP. Essentially, there are a lot of platforms already out there today that support WebGPU. And the support to add WASI WebGPU it's not too much work, essentially. If they already have WebGPU, it's fairly straightforward to do what we need to run server side. The main tricks are just essentially some of the web APIs we don't have access to. So we have a slightly different interface binding, but a lot of that can be automated. Long-winded way of saying yes. I think it would be amazing if Candle had a WASI WebGPU backend that you were able to build with. And Mindy's a good person to reach out to on Slack. He has there's sort of a mix of things right now. I just shared an example that he demoed actually at the WebAssembly CG yesterday. There's caveats basically. A lot of this is brand new, so I'm blocking him actually on not doing this code review yet. I owe him that one for landing that in the header space. There's some work to be done upstream. Dawn is essentially what a ton of people build with. It's what Llama needed in this case. And then, for other things to get working, he's kind of brought a lot of things together. So there's kind of branches of branches, which can be hard to work with. But the ultimate goal is everything lands upstream and on main, and you don't have to know the right tricks. And in the South, we have a saying for this. It's called "hold your mouth right." So whenever you're doing something, if you've ever seen a woman put on mascara, for example, they make the silliest faces you've ever seen, like to be able to do it, and it shouldn't impact anything. But for some reason, you've got to kind of hold your mouth right to be able to make it all work together. So anyways, right now it's in that kind of hard way of putting it together, but I think it's definitely a worthy goal of getting all of this upstreamed, because then everybody is just going to be able to build all kinds of different interesting components and run anywhere.
Really, that was a Liam level idiom. You know, like that was outstandingly obscure and completely sideways. I think Aditya's eyes were about to pop out of his head.
Well, I try not to let my accent come through too strong here, but yeah, if I talk to my mom on the phone or something and I get on a WasmCloud community call, you guys are going to think that I'm speaking a different language. And yeah, we have the craziest sayings here, so I do my very best to keep those on the DL, but for here it's like so perfect. Like it's so hard to make that work. The rest of the ones that came to mind that I almost said, I can't say on camera, so we stuck with the good ones.
I saw yours pop in. I was waiting for yours to say something about this one.
Okay. Well, hey, we've already gone 12 minutes over.
Let's not make this a contest.
So I'm gonna stop the recording now. But thank you everybody for joining, and then I'm gonna stop the recording, and maybe somebody else will give a demo after the recording isn't happening anymore. Maybe. It says I'm live streaming. I don't know how to stop it, guys.
I think you dropped it when who got toast?